Hello, this is Brian from Tavarin Games here with episode 8 in our strategy map generator tutorial series. So in this episode I want to continue our pathfinding tutorial in making it so that the pathfinding works wrapping around the edge of the map. If there's a more efficient path, there we are, on the other side, we want the unit to be able to wrap around and walk from this edge of the map to this one seamlessly. As well, we want to make sure our pathfinding works regardless of how far to the left or right we've moved the map. So if I select a unit, and the most efficient path for them to get all the way over here is actually the other way, we want that unit to walk around, and you can see that unit is now going to path across the edge of this map. Once they get there, they'll wrap to the other side, and we'll be able to watch them continue. And as well, we are offset. The map is currently not under the original grid. It's been moved. We can continue to move it, and the unit will keep moving to the correct tiles no matter how much we've moved the map. So I want to get that in today. Now, the other thing we want to do first, though, is let's get that highlight attached to the unit so we can actually see when we have them selected. So let's go to the art and drag our highlight in. Make it a child of our scout unit and put it at 0 and 0 and just rename it to our highlight. And we want to set it to order in layer of 5 since the scout is on order in layer 6. So that way it's just behind them. Okay, so let's go to our tutorial scripts, and in our unit control, we're going to need to add in a public sprite renderer, and we're going to call this the highlight. And now we need a bool to turn it on and off. So a public bool, highlight in this case, and we're going to start it as false. In our unit's update function, we can say if highlight, if I can type, we want to make it so the highlight's color is equal to new color 32, and we're going to make this 255, 255, 255, and 255, so it's just fully lit and visible. Otherwise, though, we want to set its alpha value to 0. So let's copy that, paste it here, alpha of 0. So if it's high lit, we can see it. If not, we can't. So we go to our controls, and then in the update where we select the unit, so if unit null and we hit 1, let's set the unit, and then we want to go the unit.getComponent unit control, so grabbing that script, and we want to turn the highlight equal to true when we select a unit. Let's copy that. Now, where we deselect a unit here, let's add in our new brackets. Before we set the unit to null, we want to set the highlight equal to false. That way, we unhighlight it when we deselect it. And then the other place where we swap a unit, so in this case we're changing from one to the other, we want to set the current unit's highlight to false, switch to our, switch to our new unit, and then set it to true. Okay, so that should highlight our unit. Let's go back into our game. Now let's select our scout and drag the highlight into its game object. Let's hit play on this. Okay, so it's false, we don't have it selected. Clicking around doesn't do anything. We have it selected, we click somewhere, and the unit will pathfind there. We can keep doing that. Click the unit again to deselect it, and then we don't pathfind anymore. Alright, so the highlight is working. So now, let's get our pathfinding wrapping around the edge of the map. Okay, so go back to our tutorial scripts. We need to go over to our pathfinding script, and we need to go to our getNeighbors function. So this is how we're going to add that wrapping. So one correction though from the previous video, whenever we're checking that whether the path node minus a number is greater than 0, actually needs to be greater than equal to 0. Because our nodes do go to 0. Little mistake from before, so make sure you make that correction. Okay, now we need to do our wrapping nodes. So in the case where we're actually less than 0, we then want to add our same neighbor, but instead of just subtracting 1 from it, we're going to add our grid.width minus 1. So that way we go from over here like a -1, we'll wrap around to our grid width minus 1, so that might be 49. Okay, so we can copy that, and we want to go then to our other x's where we're subtracting them, and instead we want to subtract 0.5. From it, unlike last video where I got to the very end and I forgot to change those 1s to 0.5s. This time we'll do it right, I hope. Okay, and then if we go the other way, though, if we're less than the grid width, we're fine, but otherwise if we're more than the grid width, that means we're off it. We want to take our neighborless, and we want to add or subtract our grid width from it, so we want 1 minus grid.width instead of this 1, or grid.width minus 1. Okay, so let's copy that, and then let's put that where we add 0.5. Let's do that here, and then we're going to go 0.5 plus or minus the grid width, and over here 0.5 minus the grid width. So the reason for that, we get to this end of the map, so we're at 49.5, we get to 50, that's off, or we get to 49, we get to 49.5 or 50, that's off the grid. We need to wrap around to 0 or 0.5, so that will do it. But if we just run this, the unit will never actually cross the edge, because if we're trying to go to a tile here on the left side of the map, and we're evaluating tiles over here on the right side, the H cost as the crow flies is going to calculate a large distance, and that's going to give it a large F cost. So the unit's not going to look at these tiles. So when we calculate the H cost, we do that using this calc distance function. So we need to check alternates. So we're going to need an alternate. So x alt is going to be equal to the same thing as before, this absolute value of a.x minus b.x, but we're going to add the grid.width to it first. And then we're going to check, is that value less than our calculated x distance? And if so, let's set it as our x distance. So x distance is equal to x alt. And now let's copy that bit. We don't need to redeclare the type of value. And let's subtract the grid width this time. And again, we'll set it in place if it's correct. So hopefully all that worked. Let's go back to our sample scene. And let's hit play on this. Okie dokie. So let's zoom out. Let's make sure our grid's in the right place. It looks good. Let's move our unit over to one side of the map. Now again, it's got a convenient path this way through the center, and that's going to be a shorter path than going all the way around. But once they get to that unit of the map, there should be a shorter path, maybe wrapping around down to this side of the map. So let's try to pathfind around, and it calculated a path this way. Oh, no, it's going around just fine. Okay. And now when they reach the edge, they pop over to the other side just fine. And now let's go back the other way. So they're over here. Let's try to go here. And the unit is going across the wrapping of the map as they are allowed to. Perfect. So that is working. But it's not going to work as soon as we move the map. So if we move the map over and wrap it around once, about there, if we look at the scene view, our map is now completely off the grid. If we click somewhere, we get an index out of range exception because we've clicked something that's outside of the grid. And then our unit doesn't know where to go. So we need to do a couple things. Let's first go into our path object script, or a path grid. And when we're getting the node, we can put in a bit of code to correctly compensate if we're off the grid. So we want to check if the pos.x is greater than or equal to the width. That means we are off the grid. And we want to then do a while loop. Pos.x is greater than or equal to the width. And in that, we want to basically say pos.x minus equals our width. So if we're way off on the right side of the map, our grid is over here. We're way over here. We're going to subtract the width. Okay, are we on the grid yet? Nope. We're going to subtract the width. Okay, are we on the grid yet? Yes. Stop. And our x is now correctly in the grid. And we want to do the same thing the other way. So if our pos.x is less than 0, we want to set up the while loop. So in this case, though, it's while pos.x is less than 0. We want to then add the grid width to it, plus equals the width. So that will compensate, and that will make sure it can actually get a node that corresponds to the tile you're actually clicking on, but compensating for the camera position. We're not going to be able to move to it correctly, but we can at least get it. So let's get him out of the water. Scroll out. We're going to move the map until they're back in the center. So again, our map is off the grid by a decent margin. So we can click a location, and we do get a grid width, except we're now getting our error in our pathfinding. So when the unit is trying to pathfind, it cannot get that tile because it is in the wrong spot. So we need another thing. We're going to call this our offset. And we can just set this as an integer of the, we're going to set it as a vector 2 actually. Offset, and we're going to say new vector 2, 0, 0. So we can set it from our pathfinding script, our control script and our pathfinding script, as well as modify it here. Okay, so in our controls, when we actually are sending our command to the unit's pathfind, which is down here. So we want to check if our unit is actually on the map or not, or the map grid or not. So we're going to start with a vector 2 starting position, spos. And we're going to make that equal to the unit's position. This is just to make it a little easier. Now we can check, is that position on or off the map? So if spos.x is greater than or equal to our path grid component width, so let's grab that, path grid dot width, or our spos.x is less than 0, we know that our unit is off the actual grid of the map. So we can then set our offset based on how far off the grid they are. So let's first get our component over unit control again. And we're going to set our offset dot x, and we're going to make that equal to, we're going to round one thing, seal, round up a value to an integer. We're going to take our starting position and dot x, we're going to add 1 to it, and then we're going to subtract our map width, so this get component dot width. So what this will do is this will give us a value. So if we're at 50 and the width is 50, well, we know that we're actually off the map because the map goes to 49. So we're going to take that, add 1 to it, so it's 51, and subtract the width, so it becomes 1. We're then going to divide that value by the width, and so we'll end up with, if that's 1 over 50, we're going to end up rounding that up to 1. We're going to multiply this whole thing by the width. So basically what we're returning is the number of map units we are off. So if this ends up being 101, on a 50 wide map, we know that we should be 2 off. So what we'd get is 100 plus 1, 101, subtract the width, and that gives us 51, divide by the width of 50, and that gives us 1.02 or whatever it is, round that up to 2, multiply by the width, and we get our 100 tiles off, and how far off the map we are based on the width. Otherwise, though, we just want our offset to be equal to 0. So we'll set that equal to 0. So now we are compensating when we click how far off the map the unit is when we first start our pathfinding. Okay, so we have to go back to our unit control where we're actually pathfinding. With our current node, we need to be adding our offset to it whenever we check our current node. We don't need to worry here. Let's just do it anyway out of habit. So where we're checking to hit, we need to take our current node and add our desired offset to it. And we also are going to need to see, okay, do we wrap around the edge of the map? So right here, where we have the no tile found, so we try to hit a tile at this offset, but if we wrapped around the edge of the map, there won't be a tile where we expect it to be. So we need to do a quick thing of actually calculating where the tile should be. So what we need, firstly, let's make sure we are currently above the first node, and we're actually in an upper node. And then we need to check, okay, which direction do we need to start looking for the tile we want to find? So in this case, we need the path.current node minus 1, so the previous node's x value. Subtract from it the path's current node that we're looking at, dot x. So if that is greater than 0, we need to add our width to our offset, current offset, to try and find the tile we're looking for. So offset x plus equals, now we haven't established a grid, so we're going to need to get our grid value. So let's actually declare it up here. We haven't done that yet. So we're going to make a path grid object called grid. And then we're going to grab it in our start function. So this way, no matter when our unit spawns, we can actually find the grid. So this will be equal to game object dot find game object with tag, our main camera, which our guy is attached to, dot get components dot path grid. So that will get our component off of our camera, which is tagged as main camera. Okay, so we can add in the grid.width to our pathfinding here when we can't find our node. And then we check the other direction. So the same thing, but if we are less than 0, we are going to subtract our grid width from our movement. So essentially, we set the offset when we actually first click on a tile. As well, in our path grid, we are compensating for any position we put into the get node. We are going to correct that position to then be on the grid where it's supposed to be. So that will return the correct node for the tile we clicked on, no matter how much we've scrolled. And then our unit is going to take our offset we calculated when it starts moving, and it's going to be adding that to the node it's looking at, the vector position from the node. If it finds it, it just moves to it because it knows it's now looking at the correct position. And if not, though, we are then going to basically be looking what direction is the node from our current node, and start moving in that direction until we find our tiles. So that way, after we've already started our pathfinding, but we moved the camera, this will then be able to take over for any tiles it can't find. So before, though, when we ran into the edge of the map, we just erased the path. We need to get rid of that. And we can just copy from our hit before this code where we do the hit and offset and move it down here. And we should actually hit a tile now, and let's move to it. Okay, so let's go back into our tutorial. Let's run it. All right, let's zoom out. And let's move our unit to the edge of the map. And they should be able to pathfind just fine. We haven't moved the camera yet at all. All right. Once they're there, though, they should have a path to the other side. We can look at scene view to see. It does look like there is a path to the other side. So let's click over here, and hopefully they pathfind across. And now let's move the camera. And now the edge of the map was around here. It didn't find a tile, but it correctly compensated, and the unit kept moving. So let's pathfind again. We've moved the camera. We are off the grid, but the unit is still able to pathfind on the grid or to the correct tile based on the grid, even though we are currently way off it. Let's move the camera some more, and we are currently, again, we are moving very far away. Oop, didn't mean to drag that. Let's move that back in here. So we are currently very far off the grid, and yet our unit is still able to move and pathfind on the tiles correctly. And they're able to pathfind around and wrap around, even though, again, our pathfinding grid is all the way over here, and that's what we're referencing. So there we go. We're able to get the unit to pathfind from one side of the map to the other using the closest route, even if that means going off of what we can see. And the unit's able to still move to the correct tiles no matter how we move the camera. They're able to keep moving and get to the correct tiles. Again, because we check when we don't find a tile, we compensate and tell it, okay, this is where you should look and you should find the correct tile there. And this all relies on the fact that every time we move a tile, we are moving it the exact width of the map to the other side. So its coordinates are always going to be plus or minus a width of the map. Okay, so if you made it this far in the video, as always, thank you for watching. If there's anything I could have done better or mistakes you noticed, please let me know in the comments below. In future episodes, we're going to cover getting a UI interface in place for setting the map settings and generating new maps using that. And as always, have a good one.